Hello Earth, welcome to episode 39 of season 2 of Making Cell, a series of videos where I record myself designing and implementing a programming environment called Cell. If you're just looking at these videos for the first time, I recommend you go to github.com/autocodernode/cell. Link will be pasted in the description. So where were we? We made some progress, I believe, last episode with what did we make progress? We are basically figuring out how to have some sort of intermediate writing space when we're processing a sequence, a function. So continue where we left off. We had a bunch of logs. I'll just remove them from here. So we basically are, this is what we had from last episode. We did the manual expansion, saying, okay, you need to put this, then you need to put this, and then this gets expanded to this, then it gets expanded to this, and then finally you put the result. So we passed a modified get and put functions to actually get this done, which are here. And I was wondering why it wasn't working, but I think it was because I was calling this wrongly. If I look at the actual update here, so here I basically get each step. So this is the critical part. Pretty update. So this one, yeah, this look correct. And because we use this entire path here, I'm not overriding all the stuff that is in 11, which is fantastic and what I need. The problem with that is that there were repeated entries, I believe, right? Somewhere. Yeah. Like this too, the limiters of color here. So yeah, there's repeated stuff right here. So I wonder why it is after put. Ah, yes, because the modified get has to give me where am I repeating the paths that I'm getting? I wonder, does get do any sorting? No, it doesn't. No, isn't there a better way to do this? No. Wait, actually, yes, I can do a path to text. This is so ugly. I really want to do this here to avoid the duplicates. Now, first I need to understand where am I getting the duplicates. If I do this, the done doesn't get called. That's interesting, right? I guess nothing happens. But that's weird that nothing happens. There should be something happening, right? Yeah. Why nothing happens? I'm an idiot. This is breaking, and I am assuming this is too far. Okay, I'm passing something very funky, I guess, there. The modified put needs to do something with things, right? It's not doing anything really. So that's why it's failing, right? So in this case, okay, I need to, let's just yeah, it gets repeated the second time around. Yeah, I need to remove things that are the same. I'm just gonna go through this. Return cell paths to text path true. I'm returning an object, and then I'm getting each of the paths. Will it be like this? It's pretty cool. We can do it as text with a lossless representation of it, right? Yeah, because we can. If we go from path to text, yeah. Where's the no duplicates? Yeah, this doesn't look like text to paths. I forgot how to use my own function. It just gives you, okay, if I pass one line, I'm gonna get one path. This makes no sense, of course. Okay, that worked, right? Oops. If I sort it, perfect. What was this abracadabra? Okay, this call at the top. Okay, this is good. Got the update here. Perfect. Okay, after the update, let's just look at the modified put here. Now this is silly because I need to get the whole thing, right? But that should be done by the put. And for put, path to put, and now you get this. It seems to be stuck there. Why? I'm not really understanding what I'm doing here. I mean, I do high level, but not a low level. Just way too many logs. I need less logs. What's the actual put I use later? Just set the data space to whatever you're giving me, yeah. Wow, this is good. Yeah, this is so much low. Okay, yeah, I need less. Yes, okay, we're starting to get somewhere here. So, now they have all these gets that are happening, like 4 in a row with the same stuff. And after this put, the question is 6 lines. It's the same, right? It's a sequence. It's the same thing. So I wonder where it comes from. I guess I'm running the put. When I'm running the put, for every put, I call get once. No, wait. Then I call respond n times. I call respond once. So it's just, when you get to the put here, you call it once at the top, and then one per each of those lines. So if here you have 4 lines, look. So then you have this get, which is the first one, and then you have 1, 2, 3, 4. I'm missing one. I don't know, maybe the third one already generates a fourth one, right? Yeah, because I'm calling this recursively. What I don't understand is how I'm passing to cell respond these recursive functions. Oh, in a recursive call, you lost access to that modified thing. Yeah, exactly. You just do it anew. This is way too involved, and I have to linearize it, like, and bring it to a more shallow level. Like, I don't know if I can implement this recursively. It's just too much. Why is it too much to implement recursively? Like, let's just think harder, because this is getting very ugly already. Why was that? I don't understand how this can be so hard. It has to be incremental. It has to be one at a time. And there might be like some path that is in charge of figuring out the result. We can do equal to pending, right? Something like that. And if it's equal to pending, actually not even, oh, this is even better. You have an equal of something that if you go look down, it's an actual call. Or you have an equal with something that has an at and a colon, that's even easier. Then you get it. Ooh la la, that's an interesting concept. Well, how do I put the, okay, the equal. Let's just assume we can do this. Can we do this with the same elegant one at time algorithm that expands paths one at a time for the we can check if there's an at and a colon. We look at the last result or the whole shebang and determine what the result is based on colon. So we can do that. You'll get a bunch of intermediate results for a while, but that's okay. So now for, yeah, that would work. Now for, what about the steps? Oh wait, we could add them one at a time, the steps. Just add the first step. For the steps, first add the message in colon. Also perhaps add the first step on that call. Let the first step be expanded. When you go back, you check how many steps. If there is only one, put a second one depending on the result of the first one. No error, no stop. In that way you can do it manually. These are normally solved similarly, and this is an interesting idea I never had before, which is maybe I did, but if I did, I forgot. Self-similar, so recursion, a self-similarity. Nice. Okay. So, sorry about that. It's funny we say it's been a long day, but all the days are the same length. I'm just looking at these numbers, enjoying them. Okay. So basically, the add-do. What did we learn in the last 7 sessions? Yeah, the last 7 sessions. Like that we can freeze the rightmost part. Everything. What did we learn really on the last 5 to 7 sessions? Because conditionals were a while ago. Thing to the right of the leftmost add-do by setting that leftmost add-do as the rightmost one. And then we can perhaps do this one path at a time. Okay. How? Okay, we won't have special logic for the equal. We'll let the one about at do decide. So recursive add-do. start by putting the arguments and the first step of the sequence there. If the first step of the sequence has no result, stop. Okay. Decide if this is the first time. You go in by the absence of colon. If colon doesn't exist, if there was no colon, someone would have to invent it. Sorry. If colon doesn't exist, putting the message, just a single message, just one. And the first of stop. If this is not the first time you go in, take the result of the last step. If it has no result, don't do anything, because the result will eventually come, and then with nested calls, wish me luck. But let's try to get this one working. Yes, don't do anything. Yeah. Once the last item has a result, if it's a final result, stop or error. So beautiful. We're going to handle that as a value. Yes, yes. It's liberating. Liberating. It's a single value. Go almost had it right, but they had to have those lists, and that's not nice, I think. Yeah, it will be so much better like this. If it's a final result, put it in equal. If it's not, stop error, or this is the last step in the definition. If it's not, this is gonna work. It's going to work, I think. So you just let them expand themselves, and you don't even have to pass any context or anything. It just happens, right? It would just happen. If it's not, put the next step. That's it. That's the recursive definition. Good. Yeah, we don't need any of this stuff. So now I only need to understand how to return results, because you're going to return colons and equals, right? Yeah. So, for example, how would the data be returned? This is a bit more of, but this was the thing. This was behind what was stripping me this all this time. We'll have to return multiple modifications, multiple paths. So beautiful. At once. How do we do this idempotently? We can return a list of paths. We then let the caller compare, or hell, we could do no hell for now. Them with what's there, and decide whether to call cell.put or not, because remember we only call if it's not the same, so we stop the infinite recurse there. We're just inefficient but correct. Inefficient and correct. Yes, I should try to get a PhD. No way. So it's a good thing you cannot see the camera. I will show my face because I have an incredibly bad posture right now. Yeah. And then how would we do this? Because I want to understand. I get a current value. No, this is the call to execute. And then we have a target path. Yeah, target path, and then the call is. We are comparing a previous value and a current value. So what would be it? You can just return an entire current value. Just that's easy. Well, I think, yeah. Yeah, we return everything. The at, the colon, and the equal, and let that be compared with what's already there in the caller. End of story. I'm wondering why I should go to bed. Yeah, let's go to bed now. And I will continue on the next session, but I am very excited about this because I think this is going to work, and it's very elegant, and it builds upon what is before and solves all sorts of practical difficulties. And you can see it one at a time getting expanded and just putting enough smarts on that detection. Then we of course need to get rid of all the repetition, all the necessary work we're doing, but we'll do it later. First we need to do this one at a time. All right, thank you for watching. I'll see you next episode.